Hello and welcome everyone. This session is conducted on behalf of RoboSM, and in this session I am going to introduce you to ROS. So now what is ROS? ROS stands for Robot Operating System. It is not really an operating system. ROS is an open source framework that helps researchers and developers to build and reuse code between robotic applications. Uh, ROS is like a set of tools that are required to control a robot. This means you can think ROS as of a software for all the hardware of the robot. So ROS is made by its own community and means for its own community. After several years, that resulted in a great amount of reusable packages that are simple to integrate thanks to the architecture of the system. ROS provides functionality like uh, hardware abstraction, device drivers, communication between processes over multiple machines, tools for testing and visualization, and much more. Now, why we need to use ROS? So the reason is ROS is general. The same base code and knowledge can be applied to many different kinds of robots like robotic arms, drones, mobile bases, etc. So once you have learned about how the communication is done between the nodes of the program, you can set up new parts of the application very easily. The second point is ROS has packages for everything. So ROS has packages for almost everything. For example, you need to compute a trajectory for your robot, there is a package for that. Use your joystick to control the robot, there is also a package for that. Or you want to map out your room with a drone, then there's a many packages to do that also. Now the third point is ROS is language agnostic. It means you can easily communicate between a Python node and a C++ node. It means a lot of reusability and possibilities of co-working. Now the fourth point is ROS has great simulation tools. You can't always get your robot running for real, so you need to simulation tools. ROS has many great tools such as RViz and Gazebo. Now the fifth point is you can control multiple robots with ROS. ROS can work with multiple ROS masters. It means that you can have many independent robots. Each has its own ROS system and all the robots can communicate between each other. Now the sixth point is ROS is light. The core base of ROS doesn't take much space and resources. You can quickly install the core base and get started in few minutes only. Now the second point is more and more compatible ROS products. When you build a robot, you don't necessarily want to reinvent or recreate every part of it. You might want to focus on some development points and integrate the rest from other manufacturers. The good news is here is that you can find many robotics products such as grippers, controllers, boards that already have ROS packages. Now the 8th point is ROS is an open source project with a permissive license. This is one of the greatest strength of ROS as it's open source. Most of the code packages are released under a BSD license. A BSD license allows you to modify and use the code for commercial purpose without having to release your code with an open source license. Now, the goal of ROS is to provide a standard for robotic software development that you can use on any robot. This standard allows you to actually focus on the key feature of your application using an existing foundation instead of trying to build everything from scratch by yourself. Now some main features of ROS are it runs on uh, the Linux system. It also runs on other operating systems like Mac OS and Windows, but it is not efficient on that systems. The primary system for ROS is Linux only. The main programming language that are used in ROS are C++ and Pythons. The framework that provides communication infrastructure, robotic specific features like diagnostic tools, advanced simulation capabilities. Uh, it has also many software blocks that have capabilities such as navigation, prospection, manipulation, etc. If someone wants to implement these capabilities on their robot, they can simply reuse the software from ROS and save a lot of time. Thank you.